Alright, electrolytes. You've seen these before. They're in your Gatorade, your Powerade, and you love them. So electrolytes, what are they? A substance that dissolves in water to make a solution that can conduct an electrical current. Electrical current, electrolyte. Hopefully you can make that connection there together. There's two ways you know something is an electrolyte. Number one, it has to be soluble. You're going to use that solubility chart. Looks like this on the back of your periodic table, so thankfully you don't have to memorize that. So it's got to be soluble, and it's got to be ionic. That's what this is telling you down here. So that's the first thing you always got to ask yourself. So let's go through these three questions here and see if they are an electrolyte. So calcium chloride. First thing, is it ionic? It's got a metal with a non-metal, so it definitely is ionic. Now, is it soluble? So you come over here, you find the anion, and here's your chlorine right here. So right now, chlorides are soluble, except if one of these conditions are met. And those only conditions are if it's silver, lead, or mercury. We're dealing with calcium, so it stays soluble. So it is ionic, it is soluble, so it is an electrolyte. H2SO4. Is it ionic? Yep. It's an acid, so it is ionic. Great. Now sulfates, we'll do this one in blue, are right here. So currently they are soluble unless it is with strontium, barium, lead, or mercury. We're with hydrogen, so we are definitely soluble. If we are ionic and soluble, we are an electrolyte. So then the last one, we'll do it in red, NaOH. We have a metal and a polyatomic, so it is ionic. So then you come down here to hydroxides. Now, hydroxides are at the bottom, so they are insoluble unless it is with a calcium, a strontium, or barium, an NH4, or an alkali metal. Remember, the alkali metals are group 1s. Sodium is in group 1, so it meets an exception, so it goes from soluble to insoluble, or from insoluble to soluble, because there's an exception there. So yes, this one is soluble. It is ionic and soluble, therefore it is electrolyte. Those charts take some practice to get used to. We'll get a lot of practice in class. So when something dissolves, it undergoes something called dissociation. The only thing it means is that it's split. So it only occurs if it's ionic, it's soluble in water. So now we got to do some dissociation reactions. The way you do these is first you figure out if it's ionic and soluble. We already decided that these first three were electrolytes. Great. So now we start with the compound itself, CaCl2. Now when it dissolves in water, you draw the yields arrow and the H2O, and now you split it into the cation and the anion. So here we see we have one calcium, so you write one calcium, and these are going to be charges now, so in order to conduct electricity, and calcium has a +2 charge from group 2. Plus, now we have two chlorines, so we're going to write two chlorines. Each chlorine has a -1 charge. And that's all you got to do. Just break it apart. So H2SO4, we already decided it is ionic and soluble, so therefore it is an electrolyte. So now we're going to break it apart. Start with H2SO4. Dissociate it, which means arrow with H2O on it. So now we've got two hydrogens. So two H's. Hydrogen's in group 1, so it's a +1 charge. Plus the anion, which is going to be that whole sulfate. SO4. And sulfate, if you look on your polyatomic chart, has a charge of SO2. NaOH, we already decided from the back, or the last slide, is that this is still an electrolyte. So we start with NaOH. We mixed it with water to dissociate it. And it's going to break into the cation, which is sodium. We'll have one of them. Group 1, +1 charge, plus the whole polyatomic, the OH, with a -1 charge. It's now lithium phosphate.